In question 1, part A, we have to expand 1 plus 3x to the power 6 in ascending powers of x up to and including the term in x squared. Now, for expansion of a term which is 1 plus b to the power n, the formula is 1 plus nc1 b to the power 1 plus nc2 b to the power 2 and so on. Now, the expression is 1 plus 3x to the power 6. So we'll write it as 1 plus 6c1. In place of b, we'll have 3x. So this will become 3x to the power 1 plus nc2. So that will become 6c2. And this will be 3x to the power 2. 6c1 is 6. So that will become 1 plus 18x plus, if we substitute 6c2 in the calculator, so that will become, so 6c2 is 15 and 15 times 9. So that will become 135. So this will become 135x squared. In part B, it says, hence find the coefficient of x squared in the expansion of 1 minus 7x plus x squared into 1 plus 3x to the power 6. So we first will write 1 minus 7x plus x squared. The expansion of 1 plus 3x to the power 6 was 1 plus 18x. So this is 1 plus 18x plus 135x squared. Now for the coefficient of x, we'll multiply the terms which will make an x squared. So 1 will multiply by 135. So that will become 135x squared. 7x will multiply by 18. So 7 times 18, that is minus 126. So this will be minus 126x squared. And x squared times 1 will make it a plus x squared. Simplifying this, so 135 minus 126 is 9. And 9 plus 1 is 10. So this will become 10x squared. Finally, we can write the answer for the coefficient of x squared as positive 10. In question 2, a line has equation y equals to 2cx plus 3 and a curve has equation y equals to cx squared plus 3x minus 7. Showing all necessary working, we have to determine which of the three statements are correct. So the line and curve intersect only for a particular set of value. The line and curve intersect for all values, and they do not intersect at all. Now, whenever we have an unknown constant and we want to find the points of intersection, we use the discriminant, which is b squared minus 4ac. So if it is equal to 0, it will be, the answer will be a, as there's only one point of intersection when it is equal to 0. And when it is greater than 0, they intersect for all values. And if they do not intersect, this will be less than 0. So in the first step, equating the two equations. So the equation of the curve is cx squared plus 3x minus c. The equation of the line is 2cx plus 3. Bring the 2cx plus 3 on the left-hand side. This will become cx squared plus 3x minus 2cx minus c minus 3 equals to 0. Taking x common, we can rearrange this and write it as, this will become x into 3 minus 2c. And this will remain as it is. So the coefficient of x squared is a, so a will be equals to c. The coefficient of x is 3 minus 2c, so b will become 3 minus 2c, and the constant term is minus c minus 3. Now applying b squared minus 4ac, this will become 3 minus 2c whole squared minus 4 into c into minus c minus 3. Now simplifying this, this will become 9 minus, so 3 times 2 is 6, 6 times 2 is 12c plus 4c squared. Multiplying 4c by minus c, so this will become a plus 4c squared, and minus 4c times minus 3 will become a plus 12. So 4c squared plus 4c squared will become, and this will become a 12c, so this will become 8c squared. Now minus c, 12c plus 12c will cancel out, so the final answer will be will become 8c squared plus 9. Now as for all values of c, this will always be positive. So we know that for all values, it will be positive, which means that b squared minus 4ac is greater than 0. So the answer will be that there will be intersecting for all values of c. So the answer will be B. In question 3, the diagram shows a cubical closed container made of a thin elastic material which is filled with water and frozen. During the freezing process, the length of each side of the container increases at a constant rate of 0.01 centimeter per minute. The volume of the container time t is v. We have to find the rate of increase of v when x equals to 20. Now from the question, we know that the rate of change of the length or the rate of change of x is 0.01. So we can write dx by dt is equals to 0.01. We have to find the rate of increase of v, which means we have to find dv by dt. Now the formula relating v and x will be dv by dt will be is equals to dv by dx multiplied by dx by dt. Now, as it is a cube, we know that the volume of the cube will be equals to, so the volume will be equals to length into length into length, which will become x cube. So as v is equals to x cube, dv by dx will become 3x squared. The value of x is given as 20, so substituting 20 in place of x, we'll get 3 into 20 squared. 20 squared is 400, so 400 times 3, that will become 1200. So once we have the value of dv by dx, which is 1200, we'll multiply it with the value of dx by dt, which is 0.01. So 1200 times 0. So that is 0.01. 1200 times 0.01, the value of dv by dt or the rate of increase of v will be equals to 12 centimeter cube per second. So we can write the unit 12 centimeter cube per second, or we can leave the answer as 12. Both will be marked correct. In question 4, R denotes a reflection in the x-axis and the transformation T denotes a translation of vector 3 minus 1. In part A, we have to find the equation y equals to g of x of the curve with the equation y equals to x square after it has been transformed by the sequence of transformations R followed by T. Now let's say if we have an equation of the form y equals to f of x and there's a reflection in the x direction. So let's say if we have a reflection in the x-axis. So after reflection, this equation is written as negative f of x. And if we have a translation, so let's say we have a equation y equals to f of x, and there's a translation, and the translation vector is given as a and b. So the function f of x will now be written as f of x minus a. This represents a translation of positive a units in the x direction, and plus b represents a translation in the y direction. So in our equation, the original equation is y equals to x squared. As the first transformation is r, which is a reflection, so which is a reflection in the x-axis. So this whole equation will multiply by a minus sign, and this will become minus x squared. In the second step, after the reflection minus the equation y equals to minus x squared, it will be translated, and the vector is, so the translation vector is given as 3 and minus 1. So this equation will be written as y is equals to minus x minus 3, which represents a translation of 3 units in the x direction, and minus 1. So this represents a translation of minus 1 in the y direction. So the final equation will be y equals to minus bracket x minus 3 whole squared minus 1. In part B, it says find the equation h of x of the curve with the equation y equals to x square after it has been transformed by the sequence of transformation t followed by r. Now, as in this case, the first transformation is a translation. So after a translation, this will be written as y is equals to x minus 3 whole squared minus 1. And it is followed by r, which is a reflection in the x-axis. So the equation now is y is equals to x minus 3 whole squared minus 1. So in the first step, there was a translation with vector 3 and minus 1. And after the translation, there will be a reflection, and the reflection is in the x-axis. So we'll multiply the whole equation by a negative sign. So this will become minus x minus 3 whole squared, and this will become a plus 1. In part C, it says that state fully the transformation that maps the curve y equals to g of x. Now in part A, the final equation that we got was y equals to minus x minus 3 whole squared minus 1, which was basically g of x. So we can write that g of x is equals to minus x minus 3 whole squared minus 1. And it is transformed onto the curve y equals to h of x. So in part B, the equation that we found out was basically h of x. So h of x is minus x minus 3 whole squared minus 1. So we have to find the transformation that will map G onto H. Now we can see that over here, everything is the same. The only difference is, so this was a plus 1 over here. This minus 1 has now become a plus 1. Now this basically represents a translation of 2 units in the x direction, as everything else is the same. So we'll say that from G of x to H of x, there will be a translation, and there's no translation in the x direction, so the vector will be 0 and positive 2 units in the y direction. So the final answer we can write as a translation of vector 0 and 2. Question 5a, we have to show that the equation 4 sin x plus 5 upon 10x plus 2 upon sin x equals to 0 may be expressed in the form a cos square plus b cos x plus c, where a, b, and c are integers. So in the first step, the equation is 4 sine plus 5 upon tan. Now we know that tan x is equals to sin x upon cos x. So when we substitute sin x upon cos x, this can be written as 5 cos x upon tan x, cos x upon sin x, plus 2 upon sin x is equals to 0. Taking the LCM, so this is a sin x over here, and this is also sin x. Now taking the LCM, so the LCM will become sin x. There's a 1 over here, so this will multiply by sine. So this will become 4 sine squared plus 5 cos plus 2 is equals to 0. So sine will multiply by 0, and the equation will be 4 sine squared plus 5 cos plus 2 equals to 0. We know that the identity is sine squared plus cos squared equals to 1. So sine squared can be written as 1 minus cos squared. So substituting 1 minus cos squared in place of sine squared, this will become 4 into 1 minus cos squared plus 5 cos plus 2 equals to 0. Expanding this, we'll get 4 minus 4 cos squared plus 5 cos plus 2 equals to 0. So this will become minus 4 cos squared plus 5 cos, and this will become 4 plus 2 plus 6 equals to 0. Now, as we have to bring the cos squared term in positive, so we can change the sign and write it as 4 cos squared minus 5 cos minus 6 equals to 0. In part B, it says, hence solve the equation 4 sine plus 5 upon tan plus 2 upon sine equals to 0 for 0 to 360. So in the first step, we already have converted this to cos form, which is 4 cos squared minus 5 cos minus 6 equals to 0. Applying middle term breaking, so we'll get, we have to get minus 24 and minus 5. So we'll use minus 8 cos plus 3 cos minus 6 equals to 0. Taking 4 cos common, we'll get cos minus 2. And taking 3 common, we'll get cos minus 2 equals to 0. Simplifying, we'll get cos minus 2 and 4 cos plus 3 equals to 0. So finally, the equation will be cos theta will be is equals to 2 and cos theta will be is equals to minus 3 upon 4. Now, as cos cannot be greater than 1 or less than minus 1, so we'll reject cos theta is equals to 2 as it will give no solutions. Now for this, first we'll find the basic angle. So the basic angle will be cos inverse of 3 upon 4. Substituting this in the calculator, so we'll get 41.409 as the basic angle. So this will become 41.409 degrees. Now as cos is negative over here, so first we can make the 4 quadrants. We know that cos is positive in the first and the fourth quadrant, but as there's a negative sign, so we'll make this basic angle in the second quadrant. This angle is 41.409, and in the third quadrant, this angle, the basic angle, which is always made with the x-axis, is 41.409. To find x, we'll measure the angle anti-clockwise from the x direction. So the first answer will be 180 minus 41.409. So this will become 180 minus 41.409. And the second angle will be 180 plus 41.409. Writing our answer to 3 significant 1 decimal place in case of degrees. So this will become 138.6 degrees, and this will become 221.4 degrees. So the values of theta, we'll have two values, 138.6 and 221.4 degrees. In question 6, the diagram shows a motif formed by the major arc AB of a circle with radius r and center O, and the minor arc AOB of a circle also with radius r but with center C. The point C lies on the circle with center O. In part A, it's given that angle ACB is equals to k pi radians. State the value of the fraction k. Now it is talking about the angle ACB, so we can first make the angle ACB over here. Now we know that from circle properties that the angle at the center, this angle will be twice of this angle. And as all of these lengths are equal, angle AOB and ACB are equal. So this angle of the major segment and the minor segment, these two angles, we know that they obviously add to 360. So let's say this angle is X, and we know that this angle will be twice of this angle. So if this angle is X, this angle will also be X, and this will be twice of X. So we can write it as 2x plus x will be is equals to 2 pi radians, basically, which is equals to 360. So 3x will be is equals to 2 pi, and the value of x will be 2 upon 3 pi radians. So we can write that the value of k will be is equals to 2 upon 3. In part B, it says state the perimeter of the shaded motif in terms of pi and r. Now we have to find the perimeter, which means we have to find the arc length of AOB. So in the first step, finding the arc length of AOB, we know that the formula for arc length is given as r theta. So the radius is r and theta for the small sector with center C. X is 2 upon 3 pi. X is 2 upon 3. So this will become r multiplied by 2 upon 3 pi radians, and finding the arc length of the major segment AB. So this was AOB sector, and this will become the arc length of AB. So this will become arc length AB, which is basically of the major segment. We know that the radius is r, and as the angle over here is twice of 2 upon 3 pi, so that will become 4 upon 3 pi. Now, once we have these two lengths, we can add them up. So the first length is 2 upon 3 pi, which is basically the length of the smaller sector AOB, and the length of the major sector from the with center O, the length of the arc length AB, that is equals to 4 pi r upon 3. So this will become 2 pi r upon 3 plus 4 pi r upon 3. So this will become 6 pi r upon 3, which we can simplify it and write it as 2 pi r. So the perimeter of the shaded region will be is equals to 2 pi r. In part C, it says find the area of the shaded motif, giving your answer in terms of pi r and root 3. To find the area of the shaded region, now we first will find the area of this major segment. So let's make a line from over here. So first, finding the area of this major segment AOB, we know that the angle is 4 upon 3 pi and the radius is r. So in the first step, we'll find the area of major segment AOB, which will be is equals, the area is given by the formula half r squared theta. We know that the radius is r, so this will be 1 upon 2 r squared, and the angle is 4 upon 3 pi, so this will become 4 upon 3 pi. We can simplify it and write it as 4 pi r squared upon 6. So this will become 4 pi r squared upon 6. Now this part basically consisted of the unshaded region as well. Now to find the area of that unshaded region, so we can subtract it from the total area. We can first find the area of the sector AOB with center C. So we know that the angle x is 2 upon 3 pi. So finding the area of sector AOB, so area of, and we can call this as a minor segment. So area of minor segment or minor sector, basically this is a minor sector over here, AOB. we'll use the formula half r squared theta. So this will be half r squared and the angle is 2 upon 3 pi. So this will become, we can cancel the 2 and this will become pi r squared upon 3. Now from this area, we'll have to subtract the area of these two triangles. So we have the area of the sector. Now we can make it separately over here. So let's say this is AC, this is AB, and this is the point over here. We have the total area over here. Now to find, as there's a, as we have made a triangle over here, so we can find the area of one of these triangles multiplied by 2 and subtract it from the total area, which will give us the area of this unshaded part or the region in black. So finding the area of a triangle, we know that the formula for area of a triangle is half AB sine C. The radius is R and the angle is 2 upon 3 pi. So we can write that the area of one triangle will be is equals to, the formula is half AB sine C. So the two lengths will be R and R, so that will become half R squared, and the angle is 2 upon 3 pi. So this will become sine of 2 upon 3 pi. Sine of 2 upon 3 pi, when we substitute this in the calculator, that is equals to root 3 upon 2. So this will become R squared into root 3 upon 2. And this is R squared upon 2. So this will become root 3 R squared upon 4. Multiplying this by 2, as there are two triangles. So the area of two triangles will become 2 multiplied by root 3 R squared upon 4. Simplifying this, we can write it as root 3 R squared upon 2. Now, once we have the area of the two triangles as well, we can subtract it from the area of the minor sector AOB, which was pi r squared upon 3. So pi r squared upon 3 minus root 3 r squared upon 2. Taking the LCM, so the LCM in this case will become 6. So this will multiply by 2. So this will become 2 pi r squared minus, and this will multiply by 3. So this will become 3 root 3 r squared. So this basically is the area of the unshaded part. And once we have this, we can subtract it from the total area of the major segment AOB, which was 4 pi r squared upon 6. So the shaded region will be is equals to, so that was 4 pi r squared upon 6. And we'll subtract it from 2 pi r squared minus 3 root 3 r squared upon 6. Taking the LCM over here, so the LCM will be 6. And this was 4 pi r squared upon 6 over here. So this will be a 6 over here. So 4 pi r squared minus 2 pi r squared. So that will become 2 pi r squared minus minus will make it a positive. So this will become 3 root 3 r squared. We can divide both of these terms by 6 and write it as 2 pi r upon 6 plus 3 upon 6 root 3 r squared. So this will cancel out and this will also cancel out. So the final answer can be written as 1 upon 3, and this is an r squared over here. So this will become 1 upon 3 pi r squared plus root 3 r squared upon 2. So this will be the final area shaded region of the shaded region, which is basically the area of the motif. In question 7, the sum of the first two terms of a geometric progression is 15 and the sum to infinity is 125 upon 7. The common ratio of the progression is negative. We have to find the third term of the progression. Now, if it is a geometric progression, the nth term is given by a r to the power n minus 1. Now, the first term is a, the second term, so the second term will be a r to 2 minus 1, which is equals to a r. So the sum of these two terms, the first term and the second term, that is equals to 15. The sum to infinity is given by the formula a upon 1 minus r, and that is equals to 125 upon 7. So we can write 125 upon 7 will be equals to a upon 1 minus r. Now, solving these two equations simultaneously to find the value of a and r, we know that if we can take a common over here, this can be written as 1 plus r is equals to 15. So a will be is equals to 15 upon 1 plus r. Now substituting this equation into the second equation, so this is the second equation. In place of a, we can write 15 upon 1 plus r. So this will become 125 upon 7 is equals to, in place of a, we'll get 15 upon 1 plus r, and there was already a 1 minus r in the denominator. So cross multiplying, this will become 125, and 1 plus r into 1 minus r can be written as, using the algebraic identity, this will become 1 minus r squared. So this will become 125 into 1 minus r squared is equals to 7 into 15, which is 105. So 1 minus r squared will be 105 upon 125, which we can now simplify it and write it as, so taking the r squared on the right hand side, so this will become r squared will be is equals to 1 minus 105 upon 125. Taking the LCM, this will become 125 minus 105. So this will become 20 upon 125. Dividing by 5, this will become 4 upon 25. Now, as r squared is equals to 4 upon 25, taking the square root on both the sides, we'll get r will be is equals to plus minus 2 upon 5. And as the question said, that the common ratio of the progression is negative, so we'll take the final value of r as minus 2 upon 5. Now, as we have to find the third term of the progression, we need the value of a as well, and we know that a plus ar is equals to 15. So we can use this, or we can use the second equation as well to find the value of a. So using the first equation, which is a is equals to 15 upon 1 plus r. So we know that a is equals to 15 upon 1 plus r. So this will become 1 plus minus 2 upon 5. Taking the LCM, this will become 15 upon, this will be 5 minus 2 upon 5. Simplifying this will become 75 upon 3, which will be equals to 25. Now, once we have the value of a as 25 and the value of r as minus 2 upon 5, the third term will be is given by the formula ar to the power n minus 1. A is 25, r is minus 2 upon 5, and this will be n minus 1. So this will become 3 minus 1. We can write it as 25 into minus 2 upon 5 whole squared, which is equals to 25 into 4 upon 25. 25 and 25 will cancel. So the third term of the progression will be is equals to positive 4. In question 8, the diagram shows the curve with the equation y equals to 2x minus 3 to the power of 4 and y equals to 2x minus 3 whole squared plus 1, meeting at points A and B. In part A, it says by using the substitution y equals to 2x minus 3, we have to find by calculation the coordinates of A and B. So now using the substitution, the first equation will now be written as y is equals to 2 into 2x minus 3. So we'll substitute u in place of 2x minus 3 to the power 4. And the second equation will become u squared plus 1. Now we'll solve them simultaneously. So we'll equate the equation. This will become 2u to the power 4 is equals to u squared plus 1. Taking u squared and 1 on the left hand side, this will be 2u to the power 4 minus u squared minus 1 equals to 0. Now solving this equation quadratically, we can use middle term breaking over here. So this can be written as 2u to the power 4 minus 2u squared plus u squared minus 1 equals to 0. Taking 2u squared common, this will become u squared minus 1. Taking 1 common, this will become u squared minus 1 equals to 0. So this will be 2u squared plus 1 into u squared minus 1 equals to 0. So u squared will be equals to positive 1 and u squared will be equals to minus 1 upon 2. As we can find the square root of a negative number, so the value, so u squared will be 1 and square root of 1 will be, so taking the square root on both the sides, the value of u will be plus minus 1. Once we have the value of u, we can find the value of x. So as u is equals to, now as u is equals to 2x minus 3, first taking u is equals to 1, this will become 2x. So the 3 will go on the left hand side. This will be 4 is equals to 2x. So x will be is equals to 2. And the second value of x will be when we take u equals to minus 1. So taking u equals to minus 1, that will become minus 1 plus 3, which is positive 2 is equals to 2x. So the value of x will be equals to 1. Once we have the values of x, we can use either of the two equations to find the value of y. So using y equals to 2 into 2x minus 3 to the power 4. So the equation is y is equals to 2 into 2x minus 3 to the power 4. Taking x is equals to 2, so this will become 2 into 2 times 2, 4. 4 minus 3 is 1 to the power 4. So that will be equals to y is equals to 2. So when x is 2, y is also equals to 2. And when x is equals to 1, so this will become 2 minus 3 to the power 4. And in this whole case, 2 minus 3 is minus 1 to the power 4, which is also positive 1. So 2 times 1 will become 2. So the coordinates will be when x is 1, y is 2. And when x is 2, y is also 2. So the coordinates of A and B are 2, 2 and 1, 2. In part B, we have to find the exact area of the shaded region. Now, to find the area of the shaded region, we'll have to find the area under the graph, area under the equation, graph of the equation y equals to 2x minus 3 whole squared plus 1. So first we'll find the area under this region, then find the area under the region of the equation y equals to 2 into 2x minus 3 to the power 4, and then subtract the two areas. We already know that the coordinates of A and B are 1 and 2, the x coordinates. So this is 1 and this coordinate is 2. So we already have the limits as 1 and 2. So finding the area of the shaded region, first we'll find the area under the graph of the equation. So the equation above is 2x minus 3 whole squared plus 1. So this is 2x minus 3 whole squared plus 1. And we'll subtract it from the equation of the curve, which has the equation 2 into 2x minus 3 to the power 4. In the first step, integrating both the equations, we'll get 2x minus 3. This will become whole cube. We'll divide it by the new power, which is 3, and also divide with the derivative of 2x minus 3, which is positive 2. Integrating 1, that will become an x. Integrating this equation, we'll get 2 into 2x minus 3. The power will increase by 1 and become a 5. We'll divide it with the new power, which is 5, and also multiply it with the derivative of 2x minus 3, which is 2. So this 2 and 2 will cancel out. Now applying the limits in the first equation. So we know that the limits are 2 and 1. So first taking x is equals to 2. So that will become 2 times 2, which is 4. 4 minus 3 is 1. So this will become 1 cube, which is 1 upon 6 plus 2. And we'll subtract it from the lower limit, which is x is equals to 1. So this will become 2 into 1, which is 2 minus 3 minus 1 whole cube is a minus 1 upon 6 plus 1. And now applying the limits to the second equation. So that will become 2 times 2, 4 minus 3, which is 1 to the power 5. So that will become 1 upon 5, and we'll subtract it from the lower limit. So the lower limit is 1. So 2 times 1 is 1. 2 minus 3 will, so 2 times 1 is 2. 2 minus 3 is minus 1 to the power 5. So that will become minus 1 upon 5. Simplifying this, we'll get, so taking the LCM, this will become 2 times 6, 12. 12 plus 1 is 13. So this will become 13 upon 6 minus, and taking the LCM over here, so this will also multiply by 6. So minus 1 plus 6 is a 5. So this will become 5 upon 6. And this will become 1 upon 5 plus 1 upon 5. Simplifying this, we'll get 13 minus 5, which is 8 upon 6 minus, and this will become 2 upon 5. Taking the LCM, so the LCM of 5 and 6 is 30. We can write it as 30. So this will multiply by 5 and this will multiply by 5. So this will become 40 minus, and this will multiply by 6. So this will become 40 minus 12 upon 30. So the final answer will be 28 upon 30, which we can simplify and write it as 14 upon 15. So the area of the shaded region will be is equals to 14 upon 15. Question number 9a, we have to express 4x squared minus 12x plus 13 in the form 2x plus a whole squared plus b, where a and b are constants. So to convert this, we can first write the equation, which is 4x squared minus 12x plus 13 is equals to 2x plus a whole squared plus b. If we expand this expression, this will become 4x squared plus 4ax plus a squared plus b, and that is equals to 4x squared minus 12x plus 13. To find the value of a and b, we can compare the coefficients. So on the left-hand side, the coefficient of x is minus 12, and the coefficient of x on the right-hand side, that is 4a. So 4a will be is equals to minus 12, and a will be is equals to minus 3. The coefficient of the constant term on the left-hand side is 13, and on the right-hand side, that is a squared plus b. So a squared plus b will be is equals to 13. We know that the value of a is minus 3. So this will become minus 3 whole squared plus b is equals to 13. So b will be is equals to 13 minus 9. And the value of b will be is equals to 4. So we can write this expression as 2x minus 3 whole squared plus 4. In part b, it says that the function f is defined by f of x is equals to 4x squared minus 12x plus 13 for x greater than p and less than q. The function g is defined by g of x equals to 3x plus 1 for x less than 8. In part b, it says that given that it is possible to form the composite function gf, we have to find the least possible value of p and the greatest possible value of q. Now, the composite function gf basically means that in the function g, which is 3x plus 1, the x will be replaced with f of x. So this will be 3 into 2x minus 3 whole squared plus 4 plus 1. Now, as the function f is taking the place of x in the function g, and we know that the domain or the value of x for g is less than 8. So we can now write this as less than 8. So this will become 2x minus 3 whole squared plus 4, and this has to be less than 8. Simplifying this, we'll get 2x minus 3 whole squared will be less than 4. Taking the square root, we'll get 2x minus 3 will be less than. So the square root of 4 is plus minus 2. So this will be plus minus 2. Now solving this, to find the value of p and q, which are basically the x values for the function f. So we can write it as 2x minus 3 will be less than positive 2. Taking 3 on the right hand side, this will become 2x is less than 5. So x will be less than 5 upon 2. So the value of q will be 5 upon 2. And to find the value of p, we can write it as 2x minus 3 will be less than minus 2. Taking 3 on the right hand side, that will become 2x. And as this is basically less than 4. So to understand this, we can write it as we have to find the value of p and q. So x will be greater than p. So the lower value in this case will be minus 2 plus 3 over here. So this will be 2x is less than 1 and x will be less than 1 upon 2. But as this is the lower value, so this will be the value of p. These are the two values of p that we have. The two values of x, the lower value is p. So in this case, p will be is equals to 1 upon 2 and q will be is equals to positive 5 upon 2. In part C, it says find an expression for g of f of x. Now we know that g of x was written as 3 into, so that was 3 into 2x minus 3 whole squared plus 4 plus 1. So first expanding the bracket, this will become 3 into, this will become 4x squared minus, or we can write the original function of f of x, which was 4x squared minus 12x plus 13. So this will become 4x squared minus 12x plus 13 plus 1. Expanding the bracket, we'll get 12x squared minus 36x plus, so 3 times 13 is 39 plus 1. Simplifying this, so the final answer for the expression for g of f of x will be is equals to 12x squared minus 36x plus 40. In part D, it says that the function h is defined by h of x is equals to 4x squared minus 12x plus 13 for x less than 0. We have to find an expression for h inverse. Now we know that this h function is basically the same as the function f, and we converted it to the form 2x minus 3 whole squared plus 4. To find the inverse of a quadratic equation, we always have to convert it to the complete square form. To find the inverse, we'll first write y is equals to 2x minus 3 whole squared plus 4. Now exchanging the values of x and y, this will become x is equals to 2y minus 3 whole squared plus 4. Taking 4 on the right hand side, we can write it as 2y minus 3 whole squared is equals to x minus 4. Now taking the square root on both the sides, so this will become 2y minus 3 is equals to square root of x minus 4. Now taking the 3 on the right hand side, this will become square root of x minus 4 plus 3. And finally, we'll divide the whole expression by 2. So y will be is equals to square root of x minus 4 plus 3 upon 2. Now, as the square root comes with a positive and a negative sign, and we know that the value for the function h, x value is less than 0. So it means that the range for the inverse function, now this inverse function, which is basically now h inverse of x, and we can add a positive negative sign over here. We know that this h inverse of x can be written as square root of x minus 4 upon 2 plus minus plus 3 upon 2. Now, as this also has to be less than 0, so writing h of x as it is less than 0, so basically the domain of h of x was less than 0, which means that h inverse of x will also always be less than 0. So for it to be less than 0, this term must be a negative. For if this term is a positive, this whole term will become greater than 0. So the final answer for h inverse of x will be written as, so this will be 3 upon 2, and we'll take this with the negative sign so that it becomes less than 0. So the final expression for h inverse of x will be 3 upon 2 minus square root of x minus 4 upon 2. Question 10, a curve has stationary point at 2 comma minus 10 and is such that d square y upon dx squared is equals to 6x. We have to find dy by dx. Now, as the expression for d square y upon dx squared is equals to 6x, to find dy by dx, we'll integrate both the sides. So dy by dx will be is equals to 6x squared upon 2 plus c. Now, to find the value of c, the curve had a stationary point at 2 comma minus 10. So at a stationary point, the dy dx is 0 and the value of x is 2. So this will become 6 into 2 squared upon 2 plus c. Simplifying this, we'll get 6 into 4 upon 2 plus c. We can simplify it to write it as 6 into 2 plus c. So the value of c will be is equals to minus 12. So we can write the expression of dy dx as 6x squared upon 2, which is 3x squared minus 12. In part B, it says find the equation of the curve. So as the dx is equals to 3x squared minus 12, we can first integrate both the sides. So this will become y will be is equals to 3x cubed upon 3 minus 12x plus c. Now to find the value of c, we can substitute the point given in the question, which was 2 and minus 10. So this was a point on the curve. So in place of y, we'll substitute minus 10. So this will become minus 10 is equals to x cubed. So this will become 2 cubed minus 12 into 2 plus c. So minus 10 will be is equals to 8 minus 24 plus c, which is equals to minus 10 is equals to minus 16 plus c, or c will be is equals to minus 10 plus 16. So the value of c will be positive 6. Once we have the value of c, we can write the equation of the curve as y is equals to, so y is equals to x cubed minus 12x plus 6. In part C, it says find the coordinates of the other stationary point and determine its nature. Now we know that the dy dx is given by the expression 3x squared. So the dy dx was given by the expression 3x squared minus 12. For the stationary point, dy dx is 0. Solving this equation, we'll get 3x squared is equal to positive 12, or x squared will be is equals to 4. Taking the square root of 4, that will become plus minus 2. Now, as we already had x is equals to 2 as one of our points, so the other stationary point or the other coordinate will be x coordinate will be x is equals to minus 2. Once we have the value of x as -2, to find the y coordinate, we'll substitute this into the equation of the curve. So the equation of the curve was y is equals to x cube minus 12x plus 6. Substituting x is equals to -2, we'll get -2 cube minus 12 into -2 plus 6. This will become 8 plus 24 plus 6. Simplifying this, and this will be a -8. So -8 plus 24 is 16. 16 plus 6 is 22. So the coordinates of the stationary point will become 2, 22. And to find the nature of the stationary point, we'll substitute this x value into the double derivative, which was d squared y upon dx squared, which was 6x. So as d squared y upon dx squared was equals to 6x, substituting -2, this will give us a negative answer. So as d squared y upon dx squared is less than 0, it means it will be a maximum point. In part B, D, it says find the equation of the tangent to the curve at the point where the curve crosses the y-axis. Now, the equation of the curve is y is equals to x cube minus 12x plus 6. When it crosses the y-axis, it means that at the y-axis, the x coordinate will be equals to 0. So the y coordinate will become 0 minus 0 plus 6. So we have a point on the 0, 6 basically, where the curve crosses the y-axis. And to find the gradient, we know that the expression for dy dx was 3x squared minus 12. Substituting x is equals to 0. So this will become 0 minus 12. The gradient will be is equals to -12. Now, once we have the gradient of the tangent, and we have a point, we can find the equation of the tangent by using the formula y minus y1 is equals to m into x minus x1. So the y coordinate is 6. This will become y minus 6 is equals to 12 into x minus 0. Simplifying this, we'll get y is equals to 12x plus, so this was -12, so this will become -12x plus 6 as the equation of the tangent to the curve where it crosses the y-axis. Question 11, the diagram shows a circle with the equation x minus 4 whole squared plus y plus 1 whole squared equals to 40. Parallel tangents, each with gradient 1, touch the circle at points A and B. We have to find the equation of the line AB. Now, to find the equation of the line AB, as it is a tangent, and we know that the center of the circle is at the point y minus 4 and x minus 4 and y plus 1. So that means that the center will be 4, minus 1. And the tangent makes a right angle with the diameter or the radius. So as the gradient of the tangent is -1, the gradient of AB will be is equals to -1, the negative reciprocal of 1. To find the equation, we have a point 4 and -1. So the equation will become y minus -1 is equals to m, which is -1 into x minus x1, which is 4. Simplifying this, we'll get y plus 1 is equals to minus x plus 4. And we can write this equation as y is equals to minus x plus 4 minus 1. So the final equation will be y is equals to minus x plus 3. In part B, we have to find the coordinates of A, giving each coordinate in third form. Now, basically, we have the equation of the tangent and the equation of the circle. So to find the coordinates of A, we'll have to solve the equation simultaneously. Now, we know that the equation of the line AB is y equals to minus x plus 3. First, we can, so we already have this equation of the circle, which is x minus 4 whole squared. So this is x minus 4 whole squared plus y plus 1 whole squared, and that is equals to 40. And the equation of the line AB was y is equals to minus x plus 3. Now, as the line and the circle are intersecting at the points A and B, solving the equation simultaneously, so in place of y, we can substitute minus x plus 3. So this will become x minus 4 whole squared plus minus x plus 3 plus 1 whole squared equals to 40. So we substituted minus x plus 3 in place of y. Simplifying first, we'll get 3 plus 1, 4. So this will become 4 minus x whole squared equals to 40. Expanding, we'll get x squared minus, so this will become 8x plus 16. This will become 16 minus, so this will become 8x plus x squared is equals to 40. Simplifying this will become 2x squared minus 16x, and 16 plus 16 is 32, and 32 minus 40, so that will become, so 32 minus 40 is a minus 8, so this will become minus 8 is equals to 0. Simplifying this, we can write this equation as x squared minus 8x minus 4 equals to 0. Now, using the quadratic formula to find the value of x, we'll get minus, so this is a minus 8 plus minus b squared, so b is minus 8 whole squared minus 4 into ac, so a is 1 and c is minus 4 upon 2a, which is 1. Simplifying this, we'll get 8 plus minus, and this will become 64 plus, so 4 times 4 is 16 upon 2. We can write this as x is equals to 8 plus minus square root of 80 upon 2. Now we can write this equation as we have to give our answer in the surd form. So square root of 80, we can write it as 4 times square root of 4 times 20. We know that the square root of 4 is 2, so that will become 2 root 20. So the x coordinate will be 8 plus minus 2 root 20 upon 2. And dividing both of the terms by 2, so the x coordinate will become 4 plus minus, and 2 divided by 2 will become 1, so that will become 4 plus minus root 20. Now, looking at a, we know that the x coordinate will be negative as it is towards the left of the y-axis. So the x coordinate for a will be is equals to, so the x coordinate for a will be 4 minus root 20. And to find the y coordinate, we can substitute this into the equation of the line, which was y equals to minus x plus 3. So minus, and this will become 4 minus root 20 plus 3. Simplifying this, we'll get minus 4 plus root 20 plus 3. Minus 4 plus 3 is a minus 1. So this will become minus 1 plus root 20. So the y coordinate will become minus 1 plus root 20 for a. In part C, we have to find the equation of the tangent at a, giving the answer in the form y equals to mx plus c. Now we already have the coordinates for a, which are basically 4 minus root 20, and so the coordinate was 4 minus root 20 and minus 1 plus root 20, and the gradient will be, so we know from the equation that the gradient of these parallel tangents was 1. Applying the formula y minus y1 is equals to m into x minus x1. So this will become y minus y1 is minus 1 plus root 20 is equals to m is 1, x minus, and this is 4 minus root 20. Simplifying this, we'll get, so this will become y plus 1 minus root 20 is equals to x minus 4 plus root 20. And as it is multiplying by 1, it will remain as it is. Now taking 1 and root 20 on the right hand side, this will become y is equals to, so minus 4 minus 1 will become a 5. So this will become x minus 5, and this will become root 20 plus root 20, which can be written as 2 root 20. Now we can simplify root 20 as well. It can be written as square root of 4 into 5. Square root of 4 is 2, so that will become 2 root 5. So we can write this equation as x minus 5 plus 2 into 2 root 5. And the final equation will become x is equals to, so y is equals to x minus 5 plus 4 root 5 for the equation of the tangent at a.